Our next speaker is Michael Ramage, and he is in the UK as well. He's a professor of architecture and engineering and the lead for the Center of Natural Material Innovation at Cambridge University. He's coming to speak to us about regenerative urban development, and he's going to come on to the screen seamlessly now.
Can you hear me?
Hi, Michael. We can hear
Hi,
you.
Ramon.
Yes.
Can you hear me?
Yes, we can hear you. Can you hear us?
Yes, fantastic. And thank you, Jackie Ann, for that lovely talk. And we should be together in London, but we're not.
Okay. Sorry, we are slightly delayed. We had some technical difficulties getting the last speaker in. Thank you for your patience.
That's okay. I understand. Can I share my screen and then we can go to the talk?
Give me 1 second. You should. Yes, you can.
Okay. Do you see that?
No, I'm seeing the previous is yes, you're up and running. Yeah.
Okay, fantastic. Thank you very much. And it's wonderful to be with you this afternoon for you, this evening for me. Would have loved to be there in person, but the timing didn't work out. And many thanks to Shalini and others for the invitation. I'm Michael Ramage. I am CEO of Cambridge Transformation Labs, and I am a professor of architecture and structural engineering at Cambridge University. And today I want to spend a little bit of time talking about regenerative urban design and some approaches to how we get there as engineers and architects and designers of all stripes, with some examples and some thoughts, both from my work and from that of our colleagues in structural engineering. I'm going to try and time this so there's a little bit of time for questions. I know we're running late, and I'll try not to hold Neil up too much. So at Cambridge University, I lead the Center for Natural Material Innovation, where we work on using anything you can grow, really, as a replacement for steel or concrete. So timber and bamboo as very large-scale structural materials, hemp and flax as biocomposite replacements for carbon fiber and glass fiber. And primarily our concern is replacing the embodied energy and reducing the embodied energy of the built environment. Many people have spent a tremendous amount of time and effort and good energy reducing the operational energy, and now we're turning our focus to how we build with less. And at Cambridge Transformation Labs, which is a spin out from our research group in collaboration with colleagues from London in architecture and community development, we are moving away from the heroic but very exploitative past of extracting our materials from the earth and moving toward enabling the systems that allow circular bioeconomies to thrive with a connection from agroforestry to green building, green manufacturing, new jobs, and the buildings with a focus on housing, schools, and hospitals that arise from that. And we work in the paradigm of regenerative design, or I should say we work toward the paradigm of regenerative design. We are, all of us, I think, strive to do sustainable projects, and the metric there is to do no harm, and there are many wonderful examples of that. But we also know that we're in the middle of a climate crisis, and we've actually gone beyond, in many cases, what the planet can support. And so we need to move up this green arrow towards regenerative projects so that we have projects that actually give back to the planet. And what we do not only does no harm, but actually does some positive good. And this sounds fantastic. I'm definitely on board. It's also incredibly difficult to do. So I'm going to share some thoughts and some projects where we've started to get towards there. And I would encourage every one of you to get your hands on a copy of The Regenerative Structural Engineer by colleagues Oliver Broadbent and James Norman. It's an iStructD publication, and it's absolutely fantastic. I picked it up and read it in a day because I couldn't put it down. It's both philosophical and practical, and one of the things that James and Oliver highlight is that we need to look at our projects from an understanding of nature and use living systems as models for what we do as engineers, architects, and other practitioners in the built environment. And three key themes to that are the interconnections, the symbiotic resource loops, and the self-organizational capacities that we see in nature. And if we can get towards some of that in our work in the built environment, we're probably doing a good thing. So I want to talk to you a little bit about our approach at Cambridge Transformation Labs to this, and then take you through some very specific examples where I've had the good fortune to work on projects that strive towards regeneration. So, well, let's imagine an island community, many of you will be familiar, which has a need for new housing, new social housing, 500,000 houses, pick a number. One of the conventional ways, and I should say typical ways of addressing this is to find a manufacturer who can bring in products, whether they're the building materials themselves or in some cases wholly prefabricated houses, bringing those in with a significant carbon footprint, limited customization, installing them, and then departing. And we see this around the world in regions where housing is needed. We need them quickly, so we go to someone who can do them quickly for us. And one of the downsides to that is that we pay money to someone else to make it happen. And the economic outflow is real. And if we need more houses, we just have to pay more money. And at Cambridge Transformation Labs, we are working with the experience that comes from what we know from decades of research at Cambridge University to work with regions and communities on what are the natural material resources that are available, how can we make the best use of them and transform them from agricultural resources to biomaterial-based construction resources. And those materials are often then developed into products within local factories. Biomaterial buildings lend themselves to prefabrication, factory-based jobs, which tend to be safer, more gender equitable, because you go to the same place to work every day rather than random building sites around your community. And so we get good, high-quality green job creation, good knowledge transfer amongst the people working in this sector, and we can get tailored housing solutions to a particular region. And we see this contributing to sustainable development because you set this model up for 200 or 300 homes, and then the model persists. And when you need 200 or 300 more homes, you can invest a little bit more, and you're investing in your regional or your island community. So this is the model that we try and work from, and that we strive to make productive wherever we engage. And with these regenerative design examples that I'd like to show you, I want to encourage you as I talk through them that you think about the system boundaries, and that with any particular project, we think as much as possible beyond that project in time and in space. So, how did the project come to be? How can the project contribute going forward? And what does that mean? How does the project, whether it's in a city, how do the materials contribute? Where does it draw on, whether it's regional, local, or global? And at various times in each of these, we're focusing on embodied carbon or design for disassembly or design for reuse, whether it's material or space. And that resonates very much with the comment that we heard in the previous conversation about the most sustainable building being the heritage building that we already have. We'll see some development of new supply chains, new manufacturing, and new employment for people with or without skills. And I say these are imperfect examples because none of them have all of this wrapped up in one example. The goal that we strive to is to be able to do it all together. But I'm going to start with a small little bridge that's here in Cambridge, go to Rwanda briefly, Nepal, a little bit closer to your home in St. Martin, and then close with a little bit closer to my home in London. So the first project I want to talk about is the Living Link. It's a little bridge in a woodland outside of Cambridge, and it is the most literal regenerative project I've ever worked on. It's also incredibly small. We were asked to build a little bridge. It's 4 meter span over a ditch within this woodland. One side of the ditch and the other side of the ditch were not connected for quite a few hundred meters, and there were two paths that just ended at the edge of the water. So we put this bridge in. It's made out of willow, and willow is a terrible building material. It rots and it's not very strong. But if it's alive, neither of those two things are true. So we tried something by planting the structural members of the bridge in an effort to see if it could grow. And on the left, you can see the finished bridge. And on the right, you can see that within a few months, the bridge itself was sprouting. And that by giving the bridge some life, we prevented it from rotting and deteriorating. So this bridge is truly regenerative. Unfortunately, it also fell victim to vandalism, so it doesn't exist anymore. And it was truly from nature to nature. But it gave us some good insight and some good experience with actually building something that was truly regenerative and could grow. Next, I want to hop onto a plane and go to Kigali, the capital of Rwanda, where colleagues and I designed the Rwanda Cricket Stadium, which you see at the edge of the oval just below. And this project had a legacy from previous work that we did in South Africa, learning to build with earthen tiles. And the work itself has continued on to other projects in East Africa. And here we were working very much with local builders and local materials. This team made the 66,000 tiles that the building is constructed from, using the earth that was excavated to form the foundations. And over the course of a few months, they really perfected these, and I say a few months, it was actually a few weeks, perfected the technique of making these tiles and then assembling them with the thin tile vaulting technique, which comes from the Mediterranean, both Southern Europe and North Africa. And we've translated successfully a few times around the world. And so colleagues taught this method of construction to the teams in Kigali, and very quickly and rapidly they were able to take on the skill and learn the necessary technique to build this building in a very interesting place. It's a moderately seismic zone, and we designed in some reinforcing that would allow that to be a safe construction. And in just 6 months from the first bucket of the excavator into the ground to the opening of the building, the men and women of Rwanda created a truly remarkable building using earth from the site, so very conscious of the embodied energy of the material, bringing new skills to the community that built it. And when this building isn't being used as a cricket stadium, it's available for not just weddings and other parties, but it's a community HIV education center and brings people together through sport. So we took the experience that we have in materials, and many of you will remember the horrific earthquake in Nepal, and the work that we've done on bamboo allowed Anna Gatto, one of our team members and founder of Cambridge Transformation Labs, to go there and really understand what was happening in the area. And in the reconstruction, many of the houses were being designed by the global NGOs with timber truss roofs. These were self-build, but the timber was being deforested from the area. And with Anna and our group's experience in bamboo, she thought, well, you know what? Maybe there's a better way that has a local system. So working with the local communities and the local bamboo, she developed the supply chain that allowed some of the bamboo, the thinner parts, to go off to craft workers for traditional baskets, and the larger pieces of bamboo to go and get treated and become building materials. And the trusses or the bamboo then became the structural roof trusses for these new houses. So the end result is that the bamboo replaced deforested timber, and in the process, a new material economy was created for the 5,000 to 10,000 homes that were built. And this process reduced the cost from 10,000 per home to 5,000 per home. So a series of remarkably simple but thoughtful interventions helped with nature and helped with the economy. And Anna's work continued after Hurricane Irma in St. Martin, rebuilding there with the Dutch Red Cross. And this was very much a training and construction program where local people with an incredible range of backgrounds, from skilled to absolutely zero skill, got engaged with rebuilding homes on the island. And as part of this reconstruction, Anna not just led training courses, but put together a series of manuals for teaching. And many of you will be familiar with the ABCs of construction, made here in red: anchoring, bracing, and connecting, as some of the three fundamental principles to making houses more resistant to the ravages of hurricanes. And you can see on the right some of the team after the successful training and construction program. Lastly, I want to talk to you about natural, flexible, modular construction that we're working on in England. What you see here is half of a house on exhibition at the London Design Biennale in 2023. It's a home designed with engineered timber and also designed with flexible walls so that the home itself can change as the people who live in it, as their needs grow. Maybe it's one person finds a partner, those two people have children. These walls are completely flexible and can reconfigure the apartment so that the waste associated with designing and redesigning, rebuilding walls is eliminated. And these are also cheaper. They can be locally manufactured. These are a small prototype of this technique, which is called kerfing. It's the same way you make little cuts in wood to bend it to form the shape of a guitar or other musical instrument. And this exhibition and this building, it was already on its second life because the wood that we used to make it out of came from structural testing in our lab at Cambridge. So if we had had it in a building for 50 years and then we put it in a second one, we could put it in a building for another 50 years, and it was completely dismountable in about 2 hours. And so after the exhibition, we took it down. It fits on 2 pallets, shipped it back to Cambridge, and we put it up in this building. So again, if the timeline of the buildings would be typical at 50 to 70 years, we'd now be into the 2nd century of storing carbon in this timber building. And the eagle-eyed among you may recognize that this is the building that I'm sitting in at the moment. It is 100% bio-based with hemp and jute insulation. The cladding is made of hemp biocomposite. It looks like corrugated iron, but it grows nearby. And all of the windows are reclaimed. So we're very much trying to do the sorts of things that we talk about. And this building, if it ever outlives its useful life, currently can again be taken down and reused in another location. It's very modular, and that same modular system we've developed for a series of primary schools. And part of what we see in our regenerative approach to urban design is creating systems that can be reused. So we're not always reinventing buildings. And so this primary school, which is only 600 square meters, it has the components of a primary school that could be 6,000 square meters. You just add components, you add hallways, and the entire thing is a very limited number of parts. So the manufacturing of these becomes ever cheaper as we scale up. So in closing, one of the regenerative principles that we strive to achieve is that rather than designing a neighborhood or a building, we design a system from which a neighborhood or a building can emerge. So I'm thrilled to have been with you today. Thank you very much. And if there's time for some questions, I'd be delighted to answer some.
Yeah.
Thank you.
Thank you to Michael Ramage. Any questions for him before he goes to bed? Frank Johnson. Okay, Michael, get prepared
Hello.
for a difficult question.
Can you hear me? Yeah, hi, good afternoon, good evening, Michael. What were the pinning or the jointing arrangements between your spans of materials there, whether they be beams or floors or posts? What were they made of?
Yeah, really, really valuable question. Thank you. The on the building that's demountable, the connections are they're an aluminum connection that drops in, and then to make sure they don't separate, they're anchored with screws, and you take the screw out and you can just lift them out.
Why didn't you use wooden pegs?
We didn't use wooden pegs because in repeatedly taking them apart, we lose the integrity of the holes for the pegs.
Very good question, Frank. One more, anyone? Nope, that's it, Michael. Thank you very much for coming all that way.
Thank
Yeah.
you all for the invitation.
Yeah, and
I
if
hope
you
the
have-
rest of the conference is very good.
Yeah, and if we have any more questions for you, I'll ask people to put it on the chat room on the side of our Zoom link.
Yes, and feel free to share my email for follow-up later.
Thank you.
Thank you so much, Ronald, and all.
Yeah.